Now that we've discussed what screen densities are and the issues surrounding higher resolution screens, let's talk about ways we can optimize graphics for higher density displays. One of the first things you can do is to simply consider minimizing the amount of bitmapped graphics you use. If you use vector image formats like SVG or use CSS in place of simple graphics, many of the issues with scaling factors will go away. Vector graphics are resolution independent and can scale without any loss of image quality. Likewise, CSS-based graphics for simple icons and buttons will scale to any size and maintain the same sharpness and clarity. Even on lower density mobile screens, scaling is a way of life. It's very common for users to zoom in on page regions, so it's a good idea to try to make your content as scalable as you can. Of course, these approaches are not without their drawbacks. SVG images can be considerably larger than their bitmap counterparts, and vector graphics are redrawn with each pan and zoom. Both of those issues can impact performance considerably. Likewise, drawing with CSS can be effective, but you need to be aware of its limitations. Complex artwork is often out of the range of its capabilities, and often non-semantic markup is required to achieve the desired results. Support for CSS properties like CSS Transform aren't uniform yet either, so make sure that any graphics created with CSS uses properties that are well supported. You can also use icon fonts. Icon fonts are fonts populated with, you guessed it, icons. This, for example, is Modern Pictograms, which is available here at fontsquirrel.com. The great thing about these icons is that they're easy to size, and they scale automatically with your site's text. Unless you use generated content, however, you have to include unnecessary characters in your markup, which could be confusing from an accessibility standpoint. Regardless, there will be times when raster graphics are the appropriate choice. For raster graphics, you have a few options when targeting high-density screens. The basic idea is this. If you need an image to be 100 pixels by 100 pixels, you simply create the image at the scaling factor that's appropriate for the targeted screen. For example, an iOS device with a Retina display has a scaling factor of 2. So you'd create the image at 200 pixels by 200 pixels. It's important to note here that DPI does not matter. It's only about the physical amount of pixels. Now, when targeting the high-density screen, you use the high-res image and then resize it to the desired 100 pixels by 100 pixels size. Because of the default scaling factor, the additional pixels will map to hardware pixels, which will give you a much sharper and more detailed image. While this technique is relatively simple, actually targeting high-density displays can be a bit trickier. One solution is to simply not target them at all and use high-res graphics wherever you feel they're appropriate. Lower-density screens will still display them just fine, and in fact, you'll probably see improved image quality due to the scaling factors involved with lower-density screens as well. The downside to this approach is that these higher-resolution graphics are larger in size, meaning that you're asking for some of your users to download larger images than they really need. You also have the issue of the scaling factors themselves. Not every high-density screen uses the same device pixel ratio, so you'd have to account for the largest size needed, which again leads to unnecessary file sizes in most instances. If you want to target the devices themselves, you have two main options at present. First, if you're targeting CSS background images, you can use media queries to target specific device pixel ratios. Then, you simply change out the image for the high-res version and use the background size property to properly size the image. The issue here is that support for device pixel ratio isn't even across platforms, and it currently requires vendor prefixes. You're also limited to background images, meaning that context-based images using the image tag can't be swapped using this technique. To do that, you'll need JavaScript. Using JavaScript, you can query a user agent's device pixel ratio and then pass a request to use the higher res images over the lower res images. You have to be careful here in that you don't want user agents to download unneeded assets, so writing the script so that it controls resource loading properly is very important. In the end, you'll need to consider carefully whether using high-res images is appropriate at all. In perhaps one of the biggest pieces of irony in web history, mobile devices, which have the most unreliable network connections and data plans that often charge by the amount of data being used, now feature the highest resolution screens, requiring the biggest images to take advantage of them. You need to think carefully about who your users are, the context in which the images are being used, and whether or not it's appropriate to serve high-resolution images for the site. Of course, screens continue to evolve, and high-density screens are finding their way to more than just phones and tablets. It won't be long before these screens are the dominant displays across all devices. Because of this, having the ability to properly target screen density and then serve the proper assets is crucially important to web authors. There are currently a number of browser developers and standards writers working on this issue right now, so pay careful attention to how HTML and CSS change to provide this functionality. One day soon, we'll have syntax in place that allows us to specify which assets to use for which device, and how bandwidth might play a role in that selection. Currently, however, we'll need to make do the best we can using the techniques that are available to us now. That means that as a designer, you'll have to carefully consider all of your options when designing for multiple screen densities.